Today's lesson is Chapter 2, Lesson 7, Percent of Change. This will be a day where it's fine to use a calculator. So your second lesson of the year, calculators are approved. All right, so let's say that something started off at $30 and the new price was $25. We want to know what percent of change that was. What percent off was the store giving us? So in general, here's how you're going to do any of these percent of change. You're going to do a subtraction of the two numbers, and you can just subtract. If the first number is smaller, second number is smaller, it doesn't really matter. Just subtract. Subtract like you would normally subtract, get a positive number. That part's fine. Subtract, and then you're going to divide by the original number. When you do this, you're going to come up with a decimal number. And you're going to, since we want percents are out of 100, you're going to multiply by 100. Or move the decimal over 2 places to the right. If you don't want to actually hit times 100 in your mind, you can just go 2 hops to the right. Okay, so you're going to do a subtraction. Then you're going to divide by the original number. It's going to equal a decimal. But since we don't want a decimal, we want a percent. We're going to multiply by 100 or hop twice. So in this case, I'm going to do 30 minus 25, divide by 30, because 30 was the original price. This item started at $30, so I'm going to divide by 30. When I divide, I get 0.166666 repeating. Either multiply by 100 or hop twice, and the directions in the book are going to say round to the nearest whole percent. So this neighbor right here would make that go up. So final answer, 17% decrease. They also want you to say increase or decrease. So let's go back to the directions. We're going to subtract, divide by the original, get a decimal, multiply by 100. I subtracted to get 5. 30 minus 25. I divided by 30 because that's the price the item started at. 5 divided by 30 was this decimal. Hop twice, round, 17%, and it's a decrease. It went from 30 down to 25, so that's a decrease. You can write the word decrease, or I'm fine if you want to do an up arrow, down arrow to show increase or decrease. Okay, you try this question. In 2015, let's pretend our school had 235 students, and a year later they had 252 students. Find the percent of increase. Subtract, divide, hop. Did you get 7% increase? I subtracted 252 and minus 235, and I got 17. I put 17 on top. I'm going to divide it by 235 because that's the original number. That was the number we started with in 2015. So I divide by 235. I get this decimal. Calculators are okay. Hop twice. Look at the neighbor. It stays 7%. All right, let's do a sales tax question. In general, sales tax is how you're going to do it is you're going to take the price and you're going to add the sales tax, and that's your final price. So you walk up to Target and something is 99 cents. They add 5 or 6 cents of sales tax, and then they tell you that you owe $1.05, $6, $7, something like that, and that's your final price. So the sales tax is a little mini problem in and of itself. You're going to take the price times the sales tax is always a percentage, but you want to use that percentage as a decimal, which means you're going to have to hop backwards. And order of operations, we multiply, so we find that little answer to that mini problem before we add. So let's try this question. You go to buy a shirt that's $28.62. The sales tax in that city is 7.25. Every city is going to be different sales tax because part of this sales tax number goes to the city government and part of it goes to the state government. So the state of Virginia has a certain percent, but then Newport News has their percent, which might be different than Hampton, which might be different than Smithfield. So that's why this particular example, the sales tax is going to be 7.25. All right, so we're going to take the price, $28.62, we're going to add the sales tax, which is $28.62, times this guy as a decimal, which means we hop backwards twice, 0.0725, and that'll tell me my final price. Calculators are fine. When I multiply, I get 2.07495, but this is a money number, so I need to round it to money. So I only want this amount, but look at the neighbor. Does this neighbor change the 7? No, it does not. So my next line of work is going to say 2862 plus 207, and that will equal my final price, which is $30.69. Let's recap what we did. We took the price and we added the sales tax. Well, in order to get the sales tax, you have to do this mini math problem. Price times the percent as a decimal. As a decimal, you hop backwards twice. Order of operations, I multiply and get that answer. Then I add the price back to it. That's what Target would tell me I owe, $30.69 for that shirt. All right, you try this one on your own. The item is going to cost $24.99, and the sales tax in the city is 6.85%. Push pause, work it out, see if you get the same answer as me. Did you get $26.70? Remember that this money answer is $1.71. The neighbor was a 1, so it doesn't change it to $1.72. It's fine to use your calculator, but I want to see all of your work. So show me this line, show me this line. All right, let's find discounted price. If something's on sale, what's the final sale price going to be? So it looks very similar, except that it has a subtraction sign. We're going to take the price and we're going to subtract the discount. The discount is a little mini problem that is price times percent, again as a decimal, and that will tell us the sale price. What is the new price when it's on sale? Okay, let's say that the item was $85 and it was 20% off. I'm going to do $85 minus a little mini math problem here, 85 times 0.20 or 0.2. Most people just write 0.2. And that will give us our sale price, our new price, our lower price. So 85 times 0.2 ends up being 17. There wasn't any change, so I didn't have to round. $85 minus $17 is $68. So my item is now going to cost me $68. It used to be $85. It's going to cost me $68. I saved 17, but that's not what the question wants. They want the final total discounted price. You try this question. The item is $14.89 and it's 40% off. Maybe it's Hobby Lobby. They always have a 40% off coupon, which is really nice. So use your calculator, but write down all of your steps. What would the new price be, the discounted price? Did you get $8.93? In this question, make sure that you see that the 6 is a big enough neighbor to round this up. So the store is going to say $5.96. As I'm looking at your homework, there's going to be a question that asks, it's similar to this, but they're going to say, how much did you save? If they only want to know the saving price, it's right here. This is how much you saved. And then you don't have to do the subtraction. They just want this number, $5.96. All right, our last question is a word problem. And I copied it straight from the book, so you can go back and look. It's on page 120. So they're telling us that the percent of change is 10%. They're telling us that 17.22 million were in 2009. They want us to go back and find the original number. How many people were there originally? So remember I said that we would subtract, divide by the original, we would get a decimal, and then we would multiply by 100. Let's take that same idea and use these numbers, and we're going to work backwards. So I know the decimal right here. The decimal is going to be 0.10. Really, it's 0.1. Most people drop that 0. So my decimal is 0.1. That's what it equals. I know that I'm going to have a division question. I know that the original price is what I'm trying to find out. That's going to be X. I know that I'm going to do a subtraction problem, 17.22 minus X, because I don't know the original number. So now, if I make this be over 1, this looks like we have two fractions, and I can do that cross multiply and divide thing that was a couple lessons ago. So if I multiply this direction, I get 0.1x. If I multiply this direction, I get 17.22 minus x, because I'm just multiplying it by 1. So that doesn't really do anything. Now, this looks like another lesson we've already had where we had variables on both sides. So if I have variables on both sides and I have a number on the right, let's move this guy over here. So I'm going to add x, cross out what's my answer. Remember that this x is a 1x, 1.0, so I can line up my decimal places. I get 1.1x. 1.1x is equal to 17.22. Now I need to divide by 1.1, divide by 1.1. You may use a calculator to figure that part out. All right, when I divided it, I got a long decimal number. We could round it. There's no rounding directions. So I could say, unless there was rounding directions. Were there rounding directions? There were not. So I could say 15.7. Oh, I wrote 16.7. 15.7. And remember that was million people in 2007. You're going to have one question like this. You won't have a lot, but come back to this video, rewatch this when you get to that word problem if you have trouble. All right, here are your Google Classroom questions. Number 1, how do you find percent of change? So tell it to me in words, in a sentence or two. Question 2, what kind of questions are you going to do subtraction? Which questions have subtraction as one of their steps? And what kind of questions had addition as one of their steps? All right, good luck.